in front of the limit, you're going to be penalized as well. So it's very important that you will note how you ought to write your answers. Okay. Now the next few set of examples that I want to do, it's your sort of kind of complicated examples. We have dealt with a few nice examples where we had a simple function like x squared plus 1, etc. And I have once again there emphasized the importance of brackets. What I want to deal with today, I want to show you how to find the first derivative of a function which is basically which has a fraction in its expression, right? Yeah. So for example, let's take for example, and we're gonna look at these complicated ones. Let's look at, for example, h of x equal to 3 over x. So we obviously, the question is find the first derivative from first principles. And this is really a free 5-mark question. You know, it's something that we have to know. It's sort of routine. Sometimes it can get complex, but if you'll just make sure that you understand the principles or the tricks on how to deal with each type of a function when it comes to first principles, you're going to be on the safe side. So let's talk about notation while we are here. It is important to note that you are given a function h of x, not f. Therefore, when you find your first derivative, you must indicate clearly that you are finding the first derivative of a function called h. It's not f. In the information sheet, it will be given as f, but you cannot use f here. It has to make sense. You are dealing with h. So really, you don't want to lose marks over simple things, right? So this is going to be the limit again as h tends to 0. And do not worry about having two h's here. One obviously is what we have in the formula, but the other h is obviously the function itself. So do not stress about that. Now, this means that we're going to have h of x plus h minus h of x. So very, very interesting. And I think an examiner would do this to try and confuse you. So it's very important that you actually differentiate between h as a function and h as a variable. Okay. Now, we already know what h of x is. It is right here, so we don't have issues there. But we need to find what h of x, h of x plus h, you see. We need to know what that is. So obviously this means in the place of x, we're going to substitute an x plus h. And that's exactly what h of x plus h looks like. Then the next thing that we're going to do, we're going to come to the formula here and do our substitution. So h becomes, h of x plus h we know is already 3 over x plus h. And you will notice in this case, I will not really make it a big deal on brackets because my h of x is exactly one term. It's literally a single term. So the negative is not really going to catch me off guard here. But I want to emphasize again, if h happens to be more than one term, you do need to use brackets. Now, there are two ways to work around this. There's one long way, which can get a bit complicated, and that's what often leads to mistakes and errors. And then there is another one which is very quick, but it needs a very thorough understanding. So I'm going to use both methods, and then you will choose which one you want to embrace. But a very important skill that is needed here, which you have learned or should have mastered from grade 10 and maybe revised also in grade 11, is this topic called algebraic fractions. All right, where you had to find the LCD. You were just adding fractions, but up in an abstract way, right? You did not have 1 over 2 plus 3 over 4 as you would have in primary school. So this is another important concept. And if you are unclear about it, you probably want to go to my grade 10 playlist and check how algebraic fractions I actually resolved there, because you do need that. As I said the other day, grade 12 assumes you know 100% of grade 11, and grade 11 will assume you know 100% of grade 10. So if you are battling with algebraic fractions, I'm going to revise this with you right now within this problem. So I will start with the long way first before we get to the quicker way. So you will then choose which way you're going to go. So first of all, I'm going to note my numerator. It is a situation of algebraic fractions. And in my numerator, the LCD is actually x into x plus h. It's a product of those two denominators. Then I will multiply this numerator here, 3 by x. And then obviously this 3 here will be multiplied by x plus h. This is where you were told, compare your LCD with each denominator. Whatever is missing in the denominator, you multiply the numerator by, you know, that kind of a thing. All right, so I'm hoping you get it because you are in metric by now. So then I'm going to use the division sign to just avoid confusion. So I'm going to use the division sign. So I'm saying divided by h. So I've just changed the way I'm writing this. Now, what happens in the numerator is you have 3x minus 3x minus 3h. And watch this, I'm still keeping my LCD as it is. I'm not really going to multiply it out. Now, division, remember when we divide, if I have 2 over 3 and I divide this, right, by 5 over 3, what we often do is we tip and times. You remember that story of tip and times? Someone said it's KFC. You keep this, you flip that, then you change the sign, or KCF, whichever way you want to remember that. But that's what I'm going to do here. So I'm going to times this. Instead of dividing, now I'm going to times. Just a reminder that h can actually be seen as h over 1. So now I need to see at this point not an h over 1, but a 1 over h, applying that principle of tipping and timesing. Then obviously something happens in the numerator while we are at that. As you can see, 3x does take care of 3x. Now, what are you left with here? Well, let's see. You are left with the following. We have now this thing is equal to the limit as h approaches 0 of what? Of negative 3h all over, watch this now. We have x into x plus h times an h there. So remember, when you multiply fractions, you multiply numerator by numerator, denominator by denominator. So that's what I have done. I have multiplied this entire fraction by this fraction. So the 1 gets multiplied by the 3h, and the h in the denominator gets multiplied by that, okay? So again, I hope I'm not losing you there. Now, it becomes obvious then that h will divide that h, and so I'm actually going to substitute the 0 right out so that I stop writing this h approaches 0, and it becomes clear that my derivative is negative 3 over x squared. So this is how you will deal with a situation of a fraction. But as I said, there is another way you could do this. This is not the only way. So let's take it from here. I'm going to take it from this step and show you an alternative that you could have gone. An alternative is to also note the LCD is still x into x plus h. So what I'm going to do from this step is I'm going to multiply by 1. But this is not just a 1. It's a well-chosen 1. That 1 has to do with the LCD. It's actually the LCD divided by itself. Remember, any number divided by itself is a 1. So that's exactly what I'm doing. So I'm not really changing this. But the tricky part here, and this is where now it becomes important that you make your own choice, whether you want to go with the blue method or the green. So watch this now. Very, very important to note that when we multiply here, remember what I said, you're going to multiply numerator by numerator and denominator by denominator. So it's important to note that this 3 over x plus h is going to be multiplied by x times x plus h. And when that happens, I just want to show you with this one as to what exactly happens when we multiply these two. I end up with a 3 times x into x plus h all over, watch this, x plus h, this x plus h here. So what really happens is that this x plus h is going to divide that x plus h. So you are left with a 3x. So I hope you are catching that. So I'm going to be left with a 3x, and I'll do the same thing. And I hope you notice in this case, I'm going to be left with an x plus h. If you saw that, then you understand the method. If you did not see it, I would suggest you just stick to the one in blue. Right. Then, of course, we're just going to clean up quickly here. We have 3x minus 3x minus 3h all over hx into x plus h. And I hope you see from here that you're going to be left with a minus 3h over hx into x plus h, which is basically this step here. And you know exactly what to do once you are at that step. All right, so it's very interesting. Some students find the one method easy. Some students really find the other method kind of difficult and unable to deal with. So as I said here, you got to choose, weigh your options and see which one you're going to go with. All right. Then we need to do another one, right? And then this is the square root one. This is the square root one. So the square root one, let's take a function. Let's take square root of x. Let's take the square root of x. So I'm going to take, let's call this one g of x. So let's take the function g of x is equal to square root x. Keep it simple. Right. Now, obviously, we are looking for g prime of x. And we know from the formula that g prime of x will be g of x plus h minus g of x all over h. Again, do you see what I'm forgetting? I think it's because schools are closed. I'm forgetting this thing here, which is very, very important. Otherwise, I lose a mark without that. Now, if I know g of x, then I should know what g of x plus h is. And g of x plus h will be the square root of x plus h because it simply means you are substituting an x plus h in the place of x. Right. Then we're going to substitute. We are substituting an x plus h. And again, because g of x is just a single term, I'm not so much worried about brackets. And this is the part now where things get interesting. You're going to try all tricks and they're not going to work, right? But again, this is another instance where we're actually going to multiply by a 1. And in multiplying by that 1, again, as I said, this is a well-chosen 1. So we're going to multiply by what we call a conjugate. Now, let me just explain the concept of a conjugate quickly. You are actually familiar with it. It's just that we don't use the word conjugate. So in grade 11, you may have learned about surds, right? Radicals and all that. If I have 2 plus 3, the conjugate of 2 plus square root 3. The conjugate of 2 plus square root 3 becomes 2 minus square root of 3. In other words, the idea behind the conjugate is that you always want to have a difference of 2 squares. Okay, so we say x minus y is a conjugate of x plus y, or we can even say x plus y is a conjugate. Let's write this word. It's a conjugate of x minus y. So these are conjugates. These are conjugates of each other. And if you are catching this, I hope you will see then what the conjugate of this numerator is. Or by the way, we're going to take the conjugate of the numerator. So the conjugate of the numerator, please be careful. It's going to be the square root of x plus h. And instead of a minus in between, we're going to take a plus, and then we'll have x there. So this is basically multiplying by 1. And we know that multiplication by 1 in principle does not make a difference. But of course here, it will make a difference in that it will help us to solve this easily. But it does not change the value of this whole thing if we were to substitute any x value. All right. Now, let's see what happens when we multiply by the conjugate. From this blue one, we already know from difference of two squares that x plus y times x minus y is simply going to be x squared minus y squared. We know that much already. So that's exactly what's going to happen here. When I multiply those two numerators, I'm multiplying conjugates. So the result will be the difference of two squares. So which means I'm going to have an x plus h all squared minus square root of x all squared. Then I will not really worry much about what happens here in the denominator. Watch how I'm going to write this. I'm going to write this as h into square root of x plus h plus the square root of x. Now, one of the little things that you also need to remember is the following, is that a square and a square root are kind of reciprocals of each other. They kind of reverse the other, the do and undo buttons, undo and redo buttons in your computer. So for example, if I've got x squared equals to 1 and I want to get rid of the square, I take the square root. On the other hand, if I have the square root and I want to get rid of it, I will actually square. All right. So I want to get rid of the square roots here. I mean, obviously squaring here will get rid of the square roots. That's what I wanted to say. And when that happens, I've got an x plus h here minus an x. This is all over. Watch this now. We are done. We are done. So that's an x plus h plus square root x. Now watch what happens in the numerator. That happens. And then what am I left with? I want you to see this. I'm left with an h in the numerator. This is all over h. Now you see why I kept those brackets. And this h finally divides that. You are left with a 1 in the numerator. Please take note of that. And I'm going to substitute right away the 0 in the place of h. And I need you to note that you are left in this case then with 1 over square root of x plus square root of x. Now, square root of x and square root of x are actually like terms. So what happens is you add them together. Then you have 1 over 2 times the square root of x. So this is how you will deal with a square root function. And these are the complex examples which I thought I should bring to your attention because they are very important. You never know which one is going to come up in the exam. So it is important that you are prepared and you are able to do these, okay? Very, very key. Right. So we've done different examples as far as first principles is concerned. And I think then it is important that we will consider some rules of differentiation and notation. When we have done that, then then you will see how things advance. We're gonna get to more complex stuff, but we're just gonna go gently through this. So by tomorrow, I suppose we will probably be doing tangents, and all that. And very soon, before you know it, we will be sketching cubic functions. Okay, cool. Graphs of cubic functions. So Let's talk about rules of differentiation. If I were to ask you now to differentiate a number of functions using first principles, something actually interesting is going to come out of that. And I want you to see this. You can actually go and test this yourself and see if I'm telling you the truth. So if I ask you to do a couple here of this, not from first principles, yeah. If I were to ask you to do this from first principles, here's something interesting. And I can tell you now, you can go and verify this later. We just don't want to waste time, right? If I ask you to do to find the first derivative of this, then obviously you will use first principles. What is interesting is that your answer is going to be 2x. Maybe let's use a different color for the first derivatives. So this implies that the first derivative is 2x. This here would mean the first derivative is a 6x. Whereas this one here would mean the first derivative is 6x squared. Then finally, this one here would mean the first derivative is a negative 2x minus 5. Now, some of you may have done this already before and would have possibly like figured out the pattern and all that. But what I would tell you now is that you need to notice by now that when we find the first derivative, the general rule is if you are finding the first derivative of a function that is expressed in terms of x, then whatever exponent of x is, you're going to multiply that by the coefficient, which is obviously the number in front of x. So here, it doesn't seem to make a difference because the coefficient of x is 1. So 2 times 1 is a 2. That's why we have this 2 here. Then what you do is you're going to subtract 1 from the exponent, and that's why we just have x there. That is the general rule. Now, you do that for every term. And you may wonder then what happened to 3? Well, 3 also has an x term. But what I want to bring to your attention is the fact that that x term actually has exponent 0. So if you think about it, 3 times 0 is a 0, and anything multiplied by 0 is a 0. So it won't really make a difference. There is essentially a 0 there, but there's no point of writing a 0. So in other words, if I'm telling you that a letter is a constant, you've got to understand this, all right, guys? And this is where listening is going to really pay. You must know by now that the derivative of a constant is a constant. Very, very important. And I will emphasize some of these things as we go along, all right? So let's check, is this rule consistent? Look at this. 2 times 3 is a 6. That's why we've got 6 there. We subtracted a 1 in the exponent, so 2 minus 1 is a 1. It's the same thing here. Again, 3 times 2 is a 6, all right? We subtract a 1 from the exponent, and that's why we have 6x squared. Another one here, and this is what I meant when I said you got to do this for every single term in the expression. So as you can see, the coefficient here is a minus 1. So 2 times minus 1 is a minus 2. You subtract 1 in the exponent, you get a 1. Same thing here, the exponent is a 1. So 1 times 5 is a 5, or well, negative 5. It's a negative 5. And then 1 minus 1 is 0. So you see you have that x to the naught. But we know that anything to the 0 is a 1. So that is why there's no point in writing that x to the naught, because a negative 5 times a 1 will still give you a negative 5. So these are very, very important to understand. So in general, what do we say? How can we summarize this rule in general? We can say, if you want to find the derivative of any expression, watch this now. I've got an expression ax to the n. So you see, this letter x is not just there for vibes or fun. It's there for a reason. It is actually saying to you, you are finding the derivative of the expression that is inside the brackets with respect to the letter x. So in other words, you pay attention to the exponents of the letter x. Everything else is going to be treated as a constant. What I just said now is very important for what we will be doing later. So in general, we will say then, this is equivalent to what? What are you going to do? Well, the exponent is an n. It must be multiplied by the coefficient, which is a. So that's going to be your first thing. And then you have x to the n minus 1. So that's going to be your derivative. And if you look at all these examples, they are following this rule. Okay, very, very important to note that. Now, what I'm going to do, because this is very, very important, guys, I'm going to give you a few expressions to play with. I'm going to ask that you find the derivative. And the reason I'm doing this, because I want to show you the different ways in which you can be asked to find the derivative. Okay, so pay attention to these different ways. But it's the same question. As I said, in language, you have synonyms. So it is in mathematics. We can have different ways of saying one and the same thing. So watch what is about to happen. So determine the following. In fact, I think I will just do it so that when I give you another one, it is quite fair. So determine the following. A, or example 1, what are you going to determine? You're going to determine dx of 2x cubed. That's the first thing that we're going to do. For those of you who want to get ahead and do this, you are welcome. Secondly, you're going to find the following. You're going to find f prime of x if f of x is equal to 3x squared. That's what you're going to do. And then number 3, you're going to find dy dx if y is equal to x to the 4. And then maybe the fourth one to add, which is also quite important to note, you will find dx of what? 12. Let's still use square brackets. Could be square brackets or round brackets. Well, maybe let's take 17 for KDB. All right. Now, let me tell you one thing. All these things, you see how different they are written. They simply mean one thing. Apply the rule in green. That's what they are telling you. Apply this rule. That's all they're saying. Okay? So what we're going to do, the first one, we're simply going to apply the rule. 3 times 2 is a 6. Subtract 1 in the exponent, you get an x squared. So that's your first derivative. You are done. Number 2, find first derivative of f if f of x is 3x squared. So again, you know what f of x is. F of x is 3x squared. Therefore, f prime of x is equal to 6x. Take note that if you're going to write this, then this, without saying f prime x, you might as well forget about that mark, because there is surely a difference between f of x and f prime of x. So I hope you pay attention there. Again, dy dx, watch, y is equal to x4. So what dy dx is saying to you is find the derivative of this expression called y, but with respect to the letter x. So that will be 4x cubed. As I said, they all mean the same thing. Apply the new rule which you have just learned. Now, same thing here, d over dx. As you can see, there is something inside the bracket, and that's the number 17. We know by now that there is an x to the naught there. So if we apply the rule, the result here will be a 0. I hope we catch one another there. let me throw in another one. Let's take h of x is equal to 3x to the 6 over a 7. Now, if I want to find h prime here, it's important to note that the coefficient is the number 3 over 7. So when you bring in the 6, you are multiplying 6 by 3 over 7. And if you are not sure, you can even use your calculator for that. So your final answer will be 18 over 7 x to the 5, because 3 times 6 is actually an 18 over. So that is what the result will be. So I hope this is very much clear and there aren't issues there. Guys, this is not the end. I can promise you now there are tricks. This is an easy case. These are all easy cases, as you can see. So allow me to expose you a little bit to some other variations, okay? Sometimes they might give you a function where the letter you are differentiating with respect to is in the denominator. And here's a typical example. So since we like using f of x, let's take f of x is equal to 1 over x squared plus k. Now, if I want f of x, it is very important for you and I to note that I need the letter that I'm deriving with respect to always be in the numerator. If it is not in the numerator, it is your duty to make sure that you apply the relevant laws to have it in the numerator. So in this case, I'm going to apply laws of exponents. You may remember we have one of the laws that says if I've got 1 over a to the n and I want to write this as without a fraction, then it becomes a to the negative n. So I need to know, you need to remember this, 1 over x squared is the same as x to the negative 2, and then I'll leave that. Now, what have you done? You have rewritten the function f of x in a way that allows you to find the derivative. So now finally, we can find the derivative. F of x is equal to what? Remember, there is an invisible 1 there. So 1 times a negative 2 is a negative 2. This is x, and I subtract 1, I will get a minus 3. So very important now to note how your knowledge of integers from grade 8 comes back here in grade 12. So very, very important. Now, why do I stop at this? You may ask, what about the k? Well, this is where what I said earlier on comes into play. Remember, because you are differentiating with respect to x, you treat k as a constant. What does that mean? You treat it as any number, a 7, a 5, a negative 12, whatever number you may think of. And we know from here, we know from the previous example, that whenever you find the derivative of a number, the result will be 0. So that's why the k disappears, because it is seen as a constant. So finding its derivative will result in a 0. So that's very key to understand. Another one that I would like to bring to your attention, which is just a variation of this, watch. I will still have f of x, and I'm just going to tweak it a little bit, just give it a slight touch. So now it's 1 over 2x squared. I will still have k, or maybe let me change it to a p. Again, here, what I need you to note is the fact that now you don't just have x squared in the denominator. There is a 2 in front of that x squared. And what we often see, one of the errors, it's a trap here. The examiner knows that you're going to apply the law of exponents, and you will want to write this thing as 2 to the 2x to the minus 2, or you will even say 2 to the negative 1. Well, that one will be right if you say 2 to the negative 1. But it is important to note that you can actually leave that 2 there and just deal with the x in applying your laws of exponents. Because that is the problem. Our function is expressed in terms of x. So we need x to be in the numerator. Now, watch what happens when I find the derivative here. F prime of x is, now look at this, a negative 2 times a half. If you don't see it, maybe you want to write it down or use your calculator. So I hope you see that we're going to get a negative 1, and then we're going to get still a minus 3 there. And I'm not going to write anything else because P is treated as a constant. So the derivative thereof becomes a 0. So again, very, very important, crucial to see and note the difference between these two expressions. Another situation that you may get, imagine having h of x is equal to 3x to the 7 over x to the 4. Again, laws of exponents become useful here. It becomes important to note that this can simplify to 3x cubed. I think you know what to do from here. But all I'm trying to show you is how laws of exponents are important. Let me show you an interesting one where we have g of x is equal to square root of x. Now, we did this using first principles. The prior knowledge that is required here is your understanding of surds from grade 11. So I need to remember from grade 11 that square root x can actually be seen as x to the half. In fact, let me remind you that the nth root of anything means x to the, well, if I have m here, it will mean x to the m over n. That is why when we say square root x, it is actually because there is a 2 here and the exponent of x is 1. So this literally means, let's maybe color code this more properly. This literally means x to the 1 over a 2. That's why it's called the square root. And that's why for the cube root, what are you going to do for the cube root? If maybe there's a 2 there, what are you going to do for the cube root? To simplify that, you will say x to the, then you will say 2 over a 3. That's what you'll say. So it is very important. And you see, I'm showing you these things step one by one. There's going to be a point where they are all included in one and the same thing. And you will need to remember how to deal with each specific case. So please make sure that you are able to process this and capture it quite well. So now once I've done this, when I want g of x, it will become half x to the minus half, if you notice. And that is because half minus 1 is a minus half. All right? It's a tricky one, so do think about it and make sure you actually understand it. Similarly, if I say to you, I'm using h a lot. If I say to you, let me use different notation. If I say to you y is equal to the cube root of x, maybe let's say this is x squared, then I need you to note this means x to the 2 over 3. And then what is going to happen? When you find the derivative, which will now be dy dx, by the way, you will have 2 over 3x, but now you must think, what is 2 over 3 minus 1? All right, and that is negative 1 over 3. So these are the little things that you will need to pay attention to when dealing with differentiation. I think that's going to be pretty much enough for today. We have a day tomorrow, but before I let you go, I need you all to solve some few things or to find some derivatives for me. This is just for me to check whether I had an attentive class or not. And please feel free to ask questions. So for the next couple of minutes, I'm going to ask you to do something for me, and then I will take questions to clarify any misunderstandings. Right. So let's try this one. So I want you to find, you're going to determine dy dx in each case. if the following is given. Number one, y is equal to 3x squared plus 6x minus 12. Number two, same thing again, but here, I think I'll give you three problems. Y is equal to, watch this now, ax squared plus pi minus square root 7. Number three, I would want you to also find dy dx, given that y is equal to x to the 6 minus 3 over x plus 2 over, let's say, 5x. Well, I want the radical here. So let's hold the square root here. Yeah. X to the what? 5 still. All right. Yeah. Let me give you these three. Try them to your level best. Let's see if you have caught up with what we have discussed today. I'm going to give you about 5 minutes to do all of them, which is more than enough time. After that, we'll take questions. So very important to note, the first one is okay. There are no issues. We don't have to rewrite it. So we can get straight into the solution, and we have 6x because 3 times 2 is 6, and then plus a 6. For the constant, it is 0. So this should be your answer. Would probably give you 2 marks for that. For the second one, again, there's really nothing much except that we want you to think a little bit by having things like a, pi, and minus 7. So it is important, because I said find dy dx, your mind should just focus where there is an x. Where there's no x, you regard that as constant. So which means these two are actually constants. So when you find dy dx, it actually becomes 2 times a, which is a 2a times x to the 1, which is just x. That is that. Done. Then the last one, it is important to note that you are still differentiating with respect to x, but we have to sort out a number of things before we differentiate. So this is a case where you will rewrite the expression y. So this will be x to the 6 minus 3 times x to the negative 1 plus, watch out here, 2 to the 5 times x to the 5 over 2. Now, finally, I can differentiate because all the x terms are in standard form, sort of, meaning I have the x terms in my numerator. That's what you need when you want to differentiate this. So what is this now? This is 6x to the 5. Watch now, you are multiplying two negatives. So that must give you a positive. So this is 3x to the negative 2. Watch again, you are multiplying a 2 over 5 by a 5 over 2. That actually gives you a 1.